Okay, hopefully this will all work out. It's not the normal way I do it with a PDF inside the video, but we'll give it a shot. First question is, what relation is not a function? Remember, in a function, every x value must map to 1 and only one y value. So, the green there is legal. This red would be illegal. It's not illegal, it's just not a function at that point. And so as we look through our list, or our relations that we have here, we can see we have 2 going to 0, 3 to 0, 4 to 0. Each x is going to 1 y. It's all the same y, but still only 1. In B, we got 3 to negative 5 and negative 3 to negative 5. Each one's going to 1 value. But in C, here's our problem. We've got 1 going to 2, and 1 is going to 3. That's this case up here, where the same x is going to 2 different y values. So that is not a function. In problem 2, we're asked to find the f of negative 2. So we plug that into function f, which is negative 3, times what you're plugging in, minus 5. So we replace the x with a negative 2. Now we just work on the right-hand side here. And we go negative 3 times negative 2 is 6, minus 5, which gives us 1. Answer A. Problem 3. We have a different function here. This function is the f of, I'm going to erase a little bit of this so I have some more room. The f of x is x squared minus 3x. I want a negative 5. I'm plugging in for x. Whenever you plug in, you should always put parentheses around what you substituted. Okay, so every place I had an x, I put in negative 5, and I slapped it in parentheses. Then when you either throw that in your calculator or do it by hand, you get 25 plus 15, and that equals 40, which is answer A. And finally, our last problem on page 1, and I'm just doing 1 through 4. That's all I can fit on my screen at a time and still be able to draw. Alright, what's the domain of the graph at the right? Domain, remember, is our x values. So we're looking horizontally and kind of up and down. So for example, at x equals 0, it gets graphed. X equals negative 3, there's a point down there on the line. But at x equals 4, it gets graphed to all of these points on the vertical line, where it goes upward. But after negative 4, over here on the left-hand side, negative 5, 6, 7, and 8, there is nothing up here or down here. There's no points on the graph, the lines itself that I drew. They have an x value less than negative 4. That means all my x's are greater than or equal to negative 4. Way over here at 5 and 6, those all get graphed to points on that line. Okay, there's 1 through 4. Now 5 through 8 on the first page. We want the y-intercept. Here's our equation. For y-intercepts, remember the x value is 0, so we plug a 0 in for x. That makes this entire term 0. Negative 2 times 0 is 0. So we just have to solve 5y equals 10. Get y is 2. So when x is 0, y is 2, and that's our y-intercept. Next, we've got find the x-intercept. For x-intercepts, we let y equal 0. So here's the original equation. We're going to let y equal 0, and we'll solve for x divided by negative 3. We get negative 4/3. So negative 4/3, 0 is our x-intercept. Problem 7, I'm going to work right down here. Find the slope. We know slope is change in y, 3 and minus 9. We're change in x, 0 minus negative 3. And we get negative 6 over, with that double negative there, so it's 0 plus 3, which is 3. Slope is negative 2. Answer C. And finally, number 8, there's a couple ways to look at it. The first is they have the same x values of 8. And so if I were to graph that line, since our x's are the same, it'd be a vertical line at 8. Those have an undefined slope. And our choices are 0, 15, 16, 16, 15, or D. None of these say undefined. So it is not. D has to be our answer. Okay, problem number 9. I'm going to pause now for class. Okay, problem number 9 now. What's the equation of a line in slope-intercept form with a slope of 3 and passing through the point 1.5? Alright, we'll squeeze our work in here. The nice thing is, since they tell us it's a line, we know the form of the equation, y equals mx plus b. We know what the slope is because they told us that. So y equals, we fill in the m with 3. And then they tell us the solution to it. Since we don't know what b is, we do know that when y is 5, the x value had to be 1. And this tells us what b has to be. We can just solve that equation. You can look at it and tell b is 2, or you can subtract 3, the 3 times 1 is just 3, from both sides, and you find out b is 2. Okay, so now we have our equation. It's y equals mx, but m was 3, and we know what b is now. It's 2. Problem number 10. What is the equation of a line in slope-intercept form that passes through the point 7, 11 and 13, 17? This one, unfortunately, they didn't tell us slope, so we find slope first. 17 minus 11, change in y, over 13 minus 7, change in x. 6 over 6, it's beautiful, we have a slope of 1. So now we almost have the equation, y equals 1x mx plus b, but the m is now a 1. Again, we don't know what b is, so we choose one of our points. You can plug in 7 and 11 for x and y respectively, or 13 and 17. Let's do the smaller numbers. Let's go y is 11 when x is 7, and 1 times 7 is 7 plus b. And we find out b is 4 by subtracting 7 from both sides. So there's our equation now. Y equals 1x, which you just write as x, plus our b value, 4. So y equals x plus 4. And let's see here, that looks like answer C. Okay, let's see here. Number 11. Write the equation of a line perpendicular to this one. Perpendicular means look at the slope and fix it. I want to use the opposite reciprocal. It was negative 2 over 5. I want to use positive 5 over 2. So there's the slope I'm using. And it passes through negative 3, 1. That's going to help me find b. My equation, using this slope, 5 over 2, x plus b. And now we plug in those x's, the x and y value they gave us. Y is negative 1 when x is negative 3. Okay, you can get your calculator out to do that math if you want to. I'm going to multiply negative 3 times 5 over 2 and get negative 15 over 2. I'm going to add 15 over 2 to both sides, and when I do that, I get 13 over 2 equals b. So I know my equation now. Y equals this slope that I calculated to make it perpendicular to the negative 2/5, and my b value of 13 over 2. Answer A. And lastly on this page, what is the slope of the line at right? Horizontal line, those have a slope of 0. So that is answer A. Problems 13. What is the equation of a vertical line passing through the point 4, 7? Vertical lines all have the same equation, x equals, and then the x value that they go through. In this case, it always goes through 4, so it's x equals 4. If you ever forget that, you just draw a picture. You say, okay, it goes through 4, 7, well, that point 7 up there, and it's vertical. And so the best description for this line is x is always equal to 4 on that line. 14, a direct variation problem. Y varies directly as x. Okay? If you recall, direct variations are y equals kx. Or, if you like, the constant k is equal to the y value over the x value, the slope of it. Okay, we don't have to put delta y over delta x because y and x original are always 0, 0. It tells us that y is 7 when x is 3. So this line goes up 7 over 3. It says, what is x when y is 21? Well, we know what k is now, our slope. So it's y equals kx. It says, what is x when y is 21? So we just plug in a 21 for y. And you take 21 and you can divide it by 7/3. You can multiply 3 by 3 and get 63 equals 7x. Either way you do it, you're going to get x is 9, I believe. Multiplying by 3, I get 63 equals 7x, so x is 9. Looks like none of these. Makes me a little suspicious. I hope I did that one right. Let's double check it. K is y over x. Y is 7 when x is 3. That's my k value. Yep. And it asks for when y is 21. Okie dokie. Let's move on to 15 as I erase some of this. Problem 15. Find the vertex of this absolute value function. You got to be careful there. Our instinct might be to just say it's 1, but remember, it's what makes that stuff 0 inside. Okay, so we go 4x equals 1, x equals 1/4. Okay, so this is going to be slid over 1/4 from where it normally is. It'd be at 1/4 comma 0. The 0 comes from the fact that there's nothing on the outside of the absolute value. If you had doubts on this one, grab your calculator and graph it really quickly. Now, to be more appropriate with it, what we would do is factor out a 4 and take its absolute value. So maybe even that makes more sense. Okay, slope is 4 for this thing. It's going to go up 4 over 1, up 4 back 1. It opens upward, and it's shifted to the right by 1/4, making our vertex at 1/4, 0. Next group, problem number 16. The equation for the graph at right is, so we got to find this vertex here. Let's see if I can count 1, 2, 3, 4. So it's down 4, and it's 1, 2, 3, 4, and it's 4 left. So its vertex is -4, -4. Okay. I do have to check its slope here. Now they didn't really give me a choice, and I don't think my drawing is very good, but it does look like it goes up 1 over 1, up 1 over 1, up 1 over 1. So it's going to be just a normal absolute value, but it's going to be shifted to the right by 4 and down by 4. So we're looking for answer C. That would shift it left 4 and down 4. Equation for the graph at right. First thing I'd notice is it's shaded above the line, which means it's a greater than. That eliminates A and eliminates B. It's a dashed line, which eliminates C. It's got to be B, and we didn't do any math. Now we could check that answer. Let's see if the line, the dotted line, is graphed correctly. Y-intercept is 3. It goes up 1 over 2, up 1 over 2, up 1 over 2. So it looks like it's got to be B. 18, which equality is not equivalent to the other ones? So let's compare everything to answer A. Okay, there's what answer A is. Here's B. Now, it doesn't look like A yet, so I'm going to divide everybody by 3. And I can see that it is identical to A. So these two are equivalent to each other. Let's see if C looks that way. Pick a different color here. And here's what C is. 2x minus 3y is greater than or equal to 9. And I will move the 2x to the other side, making it negative 2x plus 9. I'll divide by negative 3. That flips the inequality. I get a positive 2/3 x plus 3. Negative 3 I divided by. Okay, that would be positive 2/3 x minus 3. positive 2/3 x minus 3. Yeah, it looks like all of them. So it must be answer D. Let's just check D really quick. So for D, I would throw the 2x over. Okay, so I got negative 3y less than or equal to negative 2x when I move it over, plus 9. I divide out negative 3, and right there I can see what's going on. When I divide the negative, that becomes a greater than symbol, and all of these other ones stayed as less thans or flip-flopped to a less than. That was right here. It changed over, oops, on that last step. So D does not look like the other ones. Now we have to find, in question 19, which points are solutions to the inequality 5x plus 3y is greater than or equal to 2. I'm not sure what is the best way to solve it, but you might just try plug and chug. Okay, we've got, let me erase a little bit of this work. Okay, all we have to do is check those x and y values and see if they make it true. So I'm going to try 0, 0 in there, and I'd get 5 times 0 plus 3 times 0, and is that stuff greater than 2? Well, is 0 greater than 2? The answer is no. It's certainly not that one. Okay, let's try negative 1, 0. I plug in negative 1, I get negative 5, and 0 for y gives me 0. Is that greater than or equal to 2? Is negative 5 greater than or equal to 2? And the answer is no. So that's not in the solution set. I'll try 0 and 2/3. I plug in 0 for x, and I get 0. I plug in 2/3 for y. The 3's cancel, I get 2, which is greater than or equal to 2. Yes, so this one checks. Let's check the 1 and negative 2/3. I throw 1 in for x, and I get 5 times 1 plus 3 times negative 2/3. I get 5. 3's are going to cancel, minus 2. I get 3, which is greater than 2, which is what we're checking. So that one works. So it looks like 3 only. Alrighty, last problem on this page. What's the slope of this line? Oh, we had a hard time with this on a test we recently took, or a quiz. Okay, you got to solve these things for y. You got to get it to that slope-intercept form. We leave the y where it's at, we move the x term to the other side. We divide by negative 5, everybody. We get negative 3, let's show that step. Divide by negative 5, negative 5, negative 5. That's a positive 3/5 x.
Teacher, sorry for the interruption. This is last call. If there's anyone that would like their photo taken, please report to the cafeteria.
Positive 3/5 x minus 3. Our slope is D, positive 3/5. Okay, next page. We got problem 21. Okay, for this equation, which has a value of negative 6, the x-intercept, y-intercept, the slope, or the origin. I don't know, let's find the y-intercept. Let's find the x-intercept. Let's start at the beginning. X-intercept, we let y equal 0. The equation quickly jumps to that. X is 4. Y is 0, x is 4. It's not that. The x-intercept is 4. Okay, let's try the y-intercept. Y-intercept, let x equal 0. So 3 times 0 is 0. You get negative 2y equals 12. Y equals negative 6. There we go. The y-intercept has a value of negative 6. 22. Determine the equation of the line shown at right in slope-intercept form. Oh boy, this is kind of a tough one. What we have to do is we have to have 2 points on the line. And it's kind of hard to find 2 points that are on this line. This is a bad test question, probably. 2, 3, it's really, really close to it. And it looks like, I don't know, let's use that point right up there. So 2, 3 it goes through. And this point looks like 6 and 5.5. If you can find other points, you can use those points. I don't see any really good points to pick. Don't use the blue ones unless a blue one is exactly on the line, and I don't think any of them really are. Okay. In fact, this first point I picked, probably could have picked something even a little bit, or made a better guesstimate at that and said it's 2 and 2.9 or something like that. Regardless, I'm going to use the ones I have in green. I'll do 5.5 minus 3 over 6 minus 2 to find my slope. It's 2.5 divided by 4, or that is 5/8. Doubling top and bottom, multiplying by a 1 essentially gives me this nice fraction. So there's my slope. Next I could find my y-intercept, and I could just stretch it out. It looks like it's 1 point something. 1.5 approximately. We'll try and figure out what the math tells us. I don't know what B is, so I use one of my points. I'm going to use the 2, 3 point. 3 for Y and 2 for X. And I'm going to find out what B is. Okay, let's erase a little of this math over here so we have some work room. Let's see here, so that's 3 equals, multiplying by 2, 10/8. Let's even multiply better. Let's simplify 2 and 8 and make that a 4. So that'd be 5/4 plus B. So I take 3 and subtract 5/4. That's going to be 7/4 equals B. So my final equation here is y equals my slope 5/8x plus my B 7/4. And I guessed B to be around 1.5. Well, 7 over 4 is equal to 1 3/4, 1.75, which is pretty darn close to that y-intercept. Last one, 23, which absolute value function is the widest? Okay, so we're comparing, is it a narrow one or is it a wide one? Well, narrow ones like this one here, these things have big slopes because they grow a lot and then run just a little and grow a lot and run a little. Whereas wide ones, they don't grow very much and run a lot. So what you end up with when your y has a small change, like let's just make it 1, and your x has a big change, let's make it 4, you have to have fractions as your coefficients out front. 0.3 is 3/10. That's going to be pretty wide. -5 means it opens upside down, but its slope is big. It's a 5. 8's a big slope. 20's a big slope. It's this decimal one here that's going to give us that wide absolute value. Again, if you didn't understand that, what you could do is graph all 4 of those equations on your calculator and just compare them and see which one is the widest. Alright, that is it.